Okay. Hey everyone. Uh, this is a game I'm building right now in the Godot game engine. It's a battle royale game. You basically, you know, blow other tanks up and try and be the last one to survive. Um, so today I want to show basically how I have my development environment set up to do native development and native engine development in Godot. So I've heard on like forums and in chat and stuff, like some people have trouble setting up their environment, their development environment for um, working with the Godot game engine and for attaching a debugger and whatnot. So I'm just going to show and share basically how to set up VS Code with the engine itself and run your projects and build the engine, compile the engine, debug the engine really easily and quickly in VS Code. So I guess the goal is, to do stuff like this. I've got this game, this tank game. I might have some part of the engine that I might want to debug, or there might be, like, for example, this function in my game code that I want to debug. But the idea is just to be able to quickly compile the engine, launch the game, launch the editor, and have a nice looking debugger available in VS Code for you to step through your native C++ and native code. So basically, what I just did, I clicked the play button, it launched my game, I set a breakpoint, and now I can step through my code, and I can use the debugger the way it's intended to. So why use a debugger in the first place? Like I was on the chat the other day, the Godot a developer chat, and just some people are just using print statements. So they're hopping into engine code and printing stuff out and then compiling the engine and running it and using like these print statements in the program output to cognitively follow the execution of the software. So I mean, for me, that was kind of a thing of the past and in an inefficient development workflow. So whenever I have the opportunity to use a debugger, I basically use it as much as possible. So yeah, very useful. I just set a breakpoint in some function in my code. I can take a look at all of the stack local variables. There's a matrix that's a frag coordinate. There's some variables that are ground, base terrain. This is a game where you blow up terrain and stuff like that. So this is a distance field function that I use to compute the distance to some arbitrary shape. But the idea is I can step through this code now. I can jump to this for loop. Actually, you can. I don't know what size is. Size is 0. If I hover over this variable in debugger mode, it'll actually tell me what the memory holds in size, and size is 0. So I'm not going to, jump into this for loop. I could actually change this memory in the debugger too. Before this, comparison is done, I can change this size to 10, and the debugger is literally going to go and write new value in that memory. And now size is 10, and now when I step through my code, it'll actually step into this for loop. Of course, it's going to crash if I do this because, reading from this array at an index that doesn't exist is probably going to crash. But the point is that I can, having a debugger attached to your program allows you to step through stuff. It allows you to look at variables. It allows me to inspect the stack. So I can see the call stack very quickly of where my program is executing right now. So I'm in some class called tank SDF fixture, and that is the top stack frame here. But I could basically jump through each stack frame and take a look at the stack variables here. This is a box2D shape class. I can inspect, a lot of the different properties of this class. I can jump to different stack frames. Here's a lot of the call forwarder binding code in the engine. Again, some more engine code, but the idea is I can actually step through the whole stack, and eventually at the top I get to like the go.main function, which is the os.run is going to be something that loops indefinitely and calls main iteration as long as this quit variable is false. But yeah, it's just very easily to step through the stack and see what's going on. The other thing too I love to do just off the hop whenever I am starting to use new software is just like look at what threads are doing what. So I mean, right now my game is 23 threads, and I don't know what all these threads are doing, but having a debugger and just attach it really quick, and I can hop into thread 23 and see what it's doing. A bunch of these are like Grand Central Dispatch or libdispatch threads that are just set up, worker threads and stuff that are just set up by some of the system libraries and on Mac or whatever. But the point is that like you can at a quick glance just see what threads are doing, and some of them are waiting on files or pulling files or something. This one looks like it's resolving some IP address. Here's some semaphore that's waiting and some rendering class or something like that. But yeah, it's interesting to be able to just quickly hop through threads and see what they're doing or waiting on or what they're pulling on, stuff like that. But yeah, the most valuable part of like a debugger is being able to like actually step through your code at runtime without having to recompile with a bunch of print statements or something, wherever. And then also be able to edit values in memory. I can change this property to, instead of 700 to 500. Just overwrite the value in that memory address in the actual program. So yeah, lots of cool stuff you can do like that with the debugger, and pretty useful tool for anyone that's doing C++ or some compiled language development. So basically I want to just show how I can just show you guys how I've got this set up for me. So I'm working on this game called Hanky Tanky or Tank Kings. We're not really sure what we're going to call it yet, but there's a lot of native stuff. There's a lot of stuff that needs to be performant. So we're running a lot of stuff in C, and we make a lot of tweaks to the engine too, just for our use case and stuff we need to change or whatever. So being able to quickly compile the engine, run it, debug it is like pretty important. So I'm not a VS Code guy either, so I just started using VS Code maybe about 3 or 4 months ago. VS Code it's become so popular. It's approachable, it's accessible, it's extendable, and all these traits have kind of led it to be have been the popularity has been kind of a result of like some of these traits of VS Code. So it's kind of grown on me a little bit, and I'm just going to share how basically I set up VS Code to build the engine, edit the engine, and debug the engine. So I guess to start, the first thing you kind of have to do, I'm going to see if I can do this on a Linux machine. I guess this is kind of be oriented for Linux and perhaps Mac OS, but I don't think in theory anything would be that difficult to kind of do the same thing on Windows, but there might be some subtleties to doing this on Windows. But at the start, you basically have to be able to check out the project. So just go to like the engine's website and read how to check out the source. Just go and clone the Git repository. And the second thing you do is install the build system. Godot uses like a build system called Sconce, which is Python based. But basically you have to install sconce build system as well to build Godot. And the last thing, I'm just building the engine right now. I just checked out a fresh copy, and it's a fairly large engine. There's a lot of different modules and stuff, but it is, once you have it compiled once, it is like fairly quick to iterate on and tweak and rebuild and launch. So it is quite nice. So check out the project, git clone it, install sconce, and go and get VS Code. VS Code, I don't know. You can just go download it. I have like a Mac and a Windows and a Linux version or whatever. So just go and install it on your platform of choice. And that's basically all you should need to kind of get set up in a development environment to build the engine and debug the engine. So when you first download Visual Studio Code and open it, it's going to kind of look like this. See if I can make this a little bit bigger here. And you basically kind of just get an empty workspace looking type window. See if I can make this a little bit larger. Zoom in. Okay, a little bit better. I'll do that one. So VS Code kind of works on a folder. You basically just open a project folder. You don't have to create a workspace like other IDEs, like Eclipse or JetBrains stuff. You just pick a folder and it will use that as the base directory for a project or workspace. So what you want to do is just open the Godot source folder and kind of use that as your base directory to work out of. So here I've got Godot checked out here, and I just opened it basically in VS Code. So the only other thing you'll have to install VS Code is, I think VS Code is written in Electron, or I don't know, whatever JavaScript flavor of the year framework is, but it won't do C++. It's not a C++ IDE by default, but it's very extendable, so you can install like a whole bunch of different language plugins. But to do C++ in VS Code and get the debugger and a bunch of the other like C++ tools, you basically want to click the extensions tab, and this is the one I'm using. I can't really comment on any of the other C++ extensions in VS Code. This one just had a lot of stars and was done by Microsoft, so this is one that I'm using right now. But basically just open VS Code, set the Godot source folder as your project folder, and install the C++ extension. So it's pretty quick. That was it. I think it's installed. That was it. I think it's done. Blah, 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 blah. Setters version 2. This update. I actually don't know what that means. Insiders. I think that's like alpha or beta, like nightly. That's me later. Sure. Okay, so you've got kind of this Godot source. You've got sconce installed, and you've got VS Code installed. And basically from here on out, it's basically the same for any platform, for Windows, Linux, or macOS. The first thing you want to do with VS Code, after you have that C++ extension installed, is to build the engine within VS Code. And the way you do that is through a build task. So you go to the terminal menu, and you can go to configure tasks. That's going to give you a list of like npm JavaScript stuff, and we don't really care about that. We want to do a C++ build. So if you scroll down to the bottom here, it'll say create tasks.json file from template. And this is going to be kind of tasks.json is, this file is how you tell VS Code what things to build, basically. and I'm just going to choose MS Build because that's kind of like the default build task for VS Code. Now let's add some interesting things. It's basically created a task called build. I'm going to rename this to be build Go.editor debug. Okay. And this is telling it that this is the name of the task. The type of task is a shell. It's the program is MS Build. That's not how we build Godot. We use the program called scones. So I'm going to substitute in scones. It might be a little bit different on your platform, but you want to basically choose scones there. And the arguments are going to be kind of the same arguments used to compile from the command. Okay, so if you read the documentation for Godot, you can pass the build different arguments depending on what type of build you want to do. But basically, you can read what those are. With my system, I'm going to do an editor build that's a debug, and that's kind of what I've labeled this task to be. And these are the arguments I'm going to pass into scones for this. I want all the, actually might even put, I think, verbose was true or yes. I actually think I want that as well. And I'm just going to delete this presentation section here. So I've just put a task into VS Code that's going to basically build the engine in VS Code the same way you build it from the command line. And to run this task, I can go to the terminal window, hit run task, and you're going to see at the very top is my task that I just created. I could call this, Jordan build Godot.editor debug, and you will see that now that's an available task to run in this run task menu. So call that just build Godot.editor debug again. I'm going to run this and just compile the engine from VS Code. Terminal, run task, build Godot.editor debug. And you can see down here in the terminal window of VS Code, it's basically running scones the way you would normally build it from the command line. And it's done. I've already built the engine with these same arguments, so it didn't actually have to do any work. But the important thing is the output of this task is a file. It's a binary file. That binary file is in the Godot source folder. Okay, so yeah, basically you can kind of see, like, after you compile the engine, it puts the, actually I'm just gonna, let's see, this directory is empty now. I'm gonna go back to VS Code. I'm gonna run that task again and just make sure that our binary file, which is the output of the build, is put into this directory here. So you can see it's empty. And the end of the Godot build is like a massive link where it's going to link all of the all these static libraries together into one binary file and put it in the bin folder. So now you can see that this executable is in the output folder. And this should be the same on Windows and the same on Linux. So now basically we're at the point where now we can compile the engine in VS Code, no problem. And you can also very easily, if you add you can add more tasks to this list and compile the engine in different ways. So for example, this compiles the engine in debug mode with the editor compiled. But if I copy that task definition, I could create another one called build Godot editor release, and it can change the target from debug to release, maybe your release debug or something. And if I save this, you'll see that I now have this task available. So now I can very quickly do a debug build of the engine, do a release build of the engine. The only thing you might just be careful about is depending on what arguments you're using to build. Sometimes, well, actually all the time, this is how the build system works with Godot, but the binary name in the Godot/build directory might be different. And that's just the way the developers have set up the project to tell at a quick glance, if you see the binary, what type of build or binary it was. So you can go in and, there's a lot of different arguments to the build. You can read the documentation for that, but very quickly you can set up a whole bunch of different ways to compile the engine very quickly by creating new tasks in VS Code and changing the arguments of the build. So I'm just going to delete this one. Actually, I'll just delete it here. Okay, so now that we can build the engine, how do we actually launch the engine and attach debugger to it? And that's done through this tab here, which is your run menu. And we haven't run the editor or the Godot project, so it's going to ask you to create a launch.json file. And I will select, as soon as you create a launch.json file, it's going to ask you for kind of like a template. Again, once you have the C++ extension in VS Code, you will get a C++ basic launch kind of template. So what actually gets put into here is going to depend on your environment. Windows and Mac and Linux are all different. This by default on Mac uses lldb as a debugger. On Linux it'll use GDB, and on Windows I don't really know, but it's pretty straightforward if you just read this. Same thing, it created a name. The type is a C++ debug launch. The request is to launch it. The program is the actual binary you want executable, and the arguments, again, same thing, command line argument stuff, things like this. Environment variables, lots of things like that. So I'm going to name this launch editor. That's it. I'm just going to say launch editor. The program name is the actual binary you want to launch. And in our case, the binary is in Godot. Actually, I can just go look and see what it was, but it's this file. And on Mac, it's godot.osx.tools.64. And that is going to be in workspace folder. This is a variable that references the current workspace folder in VS Code. And by convention, Godot puts its binaries in this bin folder. So I'm going to launch that program. If you launch that without any arguments, it brings up the Project Explorer. So we'll just test to see if this works. And I don't know what this is, but this is basically telling VS Code what debugger to attach. So we're going to try this. Basically, we can now build, and we can run the program, basically. So as soon as you edit this, I can launch editor Jordan. As soon as you save this file up here, your launch tasks will update in real time, which is pretty nice. So if I click launch editor, we're gonna see what happens, but it's basically gonna try and run that program and attach a debugger to it, and it should basically all just work for the most time. Okay, I don't like to access my downloads folder, and there we go. And basically we are running the engine right now, and we have our debugger attached as well. We don't have the editor open, and we don't have a project over or anything, but I'll show you how to do that next. So this is cool. you can either, kill the program by, closing the window, or you can go back to VS Code and you can stop the program from running here. Okay, so that's cool. But what we want to do is we already have like a Godot project that I want to open and do some engine development in. And so in that case, I want to pass the program some arguments. So I'm just gonna grab the arguments from another project that I already have open. To task, I'm gonna call launch editor project explorer, because that's basically what this is gonna do when you open Godot with no arguments. And I'm gonna totally copy this launch task and change the arguments to one of the projects I'm working on. So again, this is like the same exact task, except I'm passing it. I'm saying pass it -e. You can read about these arguments on the Godot documentation, but -e tells the binary to open the editor. --path tells the binary to try and open this project file. And I'm going to call this a launch. This is my hanky-tanky project, so I'm going to just call this. I'm going to call this launch editor hanky-tanky. And I can now just select that target here and click the play button, and it will launch that executable with those arguments, and it should just basically launch the editor with our project in it. And it has. So now I'm basically editing my project, and you'll see that it all works. And I do have a debugger attached right now. I can open up main or any file in the engine, to search for something I know that's going to be running, but I can throw a breakpoint in here, and you can see that the editor is running. And if I break on this line in this source file, the debugger is going to attach and stop there, which it just has. So now I'm basically debugging the editor, and I can do all the things that are cool, like look at all the different threads, inspect the stack, every stack frame's local variables and things like that. You can do all that stuff with. And of course, you can step through and continue like you can in any other debugger. So that's it. Debugging the engine and building the engine from VS Code. Now, the only other thing that I do set up is sometimes, before launching the executable, I actually want to make sure to always build the engine to have anything up to date. So I'm gonna tell this launch task to depend on a build task. So basically, whenever I try and launch this editor, make sure that it's built first, and make sure that this binary is up to date. And the way you do that is with another property on this task. And it's called pre-launch task. So I'm gonna change this launch task name from launch editor hanky-tanky to build and launch editor hanky-tanky. And I'm going to add one more property called pre-launch task. And pre-launch task is just another task that you want VS Code to run before this one. And if I go to tasks, I have this task here, build Godot editor debug, and I'm going to tell this launch task to depend on this other task. And so now when I go to launch, now when I hit this run button up here, it's going to go build and you'll see the output from scons here. It's going to build the engine, and then it's going to launch the engine. And so this is kind of like my default workflow is edit a bunch of source files, hit the play button. It will do the build, it'll launch the build, and attach the debugger. So that's basically the workflow. So you can see that it is doing its build right now. And, oh, I don't want to do that. I want to build and launch. Sorry, I clicked the wrong one. In fact, you know, like, I don't know. Launch, I just did the launch project explorer on. I'm going to build and launch editor. So when I click this, you can see now it's actually running the scons build. Again, I didn't change any files, but, you know, it's going to take about 10 seconds on my machine to do a null build, which is basically scons just checking all of its build dependencies, timestamps, hashes of files, globs, and deciding it really didn't need to update anything or compile anything, and then, you know, generating, you know, finish its build or whatever. So yeah, that's kind of the workflow, and that's how to set up the debugger in Godot. The last thing that I do is in VS Code is add a build. So I usually have an editor build, and I usually have a game build per project. So if I want to edit or debug the editor and modify the engine, I can do that really quickly. Or if I want to debug the game running natively, I can do that too. And all that ends up being is you pass the Godot executable different arguments. So again, the way I do is I honestly just copy my last launch task and create a new one. I don't want to do that. And I'm just going to call this build and launch hanky-tanky with no editor. And I think you have to pass the last argument when you just want to run the game as a scene file. And I believe that's going to be something like this. Scenes tank gameplay scene in this particular instance. And now I have a build and launch hanky-tanky, and also have a build and launch editor hanky-tanky. So that gives me basically a way to compile the engine, debug the engine, and you know, in editor mode, in you know, just running a game without the editor, all these types of things. And again, you can basically have a whole bunch of different tasks per project, per game, per build type, and it all just works really well with VS Code and integrated debugger. So I hope that was useful. It's certainly it's certainly worthwhile to learn how to use a debugger, and especially one that's integrated fairly well with an IDE. VS Code's debugger is not the greatest, but it gets the major things right. Stack frames, local variables, watch points, breakpoints, stuff like that. So hopefully you found this helpful, and hopefully you know, it's not too confusing. But I think I will put maybe a sample launch.json and a sample tasks.json file up in a repo somewhere, and I'll just comment it on this video, which you can, you know, if you have troubles, you can literally just grab these and stick them into a .vscode directory in the Godot or Godot source folder, then open that folder in VS Code, and it should at least give you a good starting point to getting some of these build tasks and launch tasks defined in VS Code. I'll show like the actual project I'm working on right now. I'll show exactly what my tasks and launch JSON files look like. But basically, so this is I've got a bunch of different modules as a default build. I've got a build debug that you can build whatever I do. It's just a debug build. You can also define like your environment variables as well per build. So if you have some weird, I don't know, use LLVM, you know, I don't know what environment variables you want to set, but you can just go in and set like your environment variables per build. Also, you can set environment variables in your launch.json as well if you need a particular environment when you actually launch the executable. I've got a build sanitized build where we use make sure to use address sanitizer, which I highly recommend if anybody's actually doing C++, significant C++ development. Memory or address sanitizer is like really a godsend for a lot of different things. And the instrumentation it adds to the load and the store operations is pretty minimal. It basically just results in your binary maybe running about 2 times slower, and your the quarantine memory zones it adds to your allocations ends up utilizing maybe 1.5 or 2 times more memory. But considering all of the different memory bugs it can catch, I just really highly recommend it for development purposes, because you probably aren't going to necessarily notice like a really significant slowdown or problems with it. Really, really useful for development. Yeah, so for this game, I can launch it and attach a debugger very quickly, and launch different scenes with the editor, an address sanitize build, stuff like that. And debugging works great, and everything else. So yeah, very useful.